I'm Medha Pulluru. I'm a senior at Vista Ridge High School. A lot of my friends call me Metha. That's right, meth up. And yes, meth like methamphetamine. And no, it's not because I'm high all the time. Let me tell you the lore behind my name and the story behind my research. My freshman year, my grandfather suffered from a CCM-induced stroke. Now, I'm sure many of you know what a stroke is, but what's CCM? CCM stands for cerebral cavernous malformation, and it's a brain disease that occurs on the outer covering of the brain, called the blood-brain barrier. The blood-brain barrier is made up of blood vessels, and when these blood vessels are mutated, this causes symptoms like seizures, hemorrhaging, strokes, and in many cases, death. Currently, 1 in 100 people in the U.S. suffer from CCM. That's approximately 3 million people in the U.S. alone. The FDA currently has 0 approved drugs on the market to treat CCM. And we also have no known cause as to why CCM occurs in the first place. So I guess that you're thinking by now, where does the meth come in? Well, my sophomore year, I was a debater. And as any good debater does, I was researching my topic on the effects of drugs in the brain. And when I was researching, I found something really intriguing. I found out that methamphetamine use and CCM trigger very similar neurochemical cascades in the brain. This was really fascinating to me, so I wanted to test to see if there was a correlation between methamphetamine use and actually contracting CCM. But you see, methamphetamine isn't exactly the first result on Thermo Fisher or Sierra Scientific, so I went to the next best thing, weed. You can laugh now. I'm kidding. I actually didn't get weed, but instead, I decided to test this out through computational chemistry. See, weed just doesn't have the same ring to it. So for my computational methods, I use something called Bioinformatic. Essentially, what this is doing is testing sequences and finding if they have a genetic similarity. I compared sequences related to CCM mutations, and then I compared the sequence of a fetal brain exposed to methamphetamine. We run something known as a blast analysis. And what this blast analysis does is determine if there is genetic identity between both of these sequences. So looking at these sequences, let's look at some of the results I found. So for my results, after running the blast analysis, I looked at percent identity, or the percent similarity between the sequences associated with methamphetamine and a fetal brain exposed to methamphetamine. So after looking at the comparison between both of these sequences, I found that 4 out of 5 of my sequences had a percent identity of upwards of 85%. The other one sequence had something that wasn't statistically significant, and this was determined by my e-value, or my expected value. My expected value is the likelihood of this occurring by chance, and anything less than even -3 is considered statistically significant. My one sequence that didn't determine statistical significance was called CRIT1, and it has a deletion mutation, so this trial actually further served as my control. So I guess at this point, I determined that there was something deeper going on here. This couldn't just be by chance. So I decided to just test how physically this methamphetamine interacts with the blood-brain barrier. I tried to see if there was a causation between methamphetamine use and actually contracting CCM. So the hypothesis that I was testing, one of them at least, was looking at how reactive oxygenated species, or oxidative stress, caused when someone consumes methamphetamine impacts the process of actually contracting CCM. So if you look at this diagram to your left, you can see that the CCM2 gene, the end of it, has an HHD part called the N-terminus. And this N-terminus interacts with one specific pathway called the MAPK pathway. This MAPK pathway is really significant and is associated with a lot of other neurodegenerative disorders like Alzheimer's and Parkinson's. And it's really intricate. What makes this so special is that my hypothesis was predicting that this reactive oxygenated species actually interacts with the binding between the end of this N-terminus and an upstream kinase, or the first domino in this cascade called MEC3. So when this ROS mediates between this MEC3 and the end of the N-terminus of the CCM2 gene, this can cause these CCM malformations that we were potentially trying to see if they cause. So looking at my results, I ran through something called molecular dynamics. What is molecular dynamics? Molecular dynamics determines how certain particles interact with each other. It determines how certain biological processes unfold. Through molecular dynamics, I can test how these things change over a period of time. So the two groups that I was testing were my reactive oxygenated species mediating in the MEC3 complex and without it. And I determined binding affinity, or the strength of the bond when these two things interact. So the values that I got for this binding affinity, the more negative the significance. So I got negative 8.763 for one of them and negative 8.432. And the first one was determining based on the Ross mediation. So when the reactive oxygenated species actually interacts in this complex, the strength of the bond is actually higher, suggesting that when you use methamphetamine, this actually creates the likelihood of actually contracting CCM, which is what I was testing. Computational chemistry and other sort of computational methods are incredibly efficient, simply because they save us thousands of dollars worth of resources in the lab and decades of research. Being able to use my bioinformatics methods and molecular dynamics, I was able to pinpoint specifically where I wanted to test out things in the lab without having to take a shot in the dark. And so this is exactly what I did. When I actually stepped foot in the lab, I used an organism called C. elegans, a small microscopic roundworm that's commonly used in a lot of neuro research. Essentially what I was doing is that I had 4 groups of worms. 2 of these worms were the N2 strain, my control strain that didn't have any mutations, and the other 2 were mutated to have a greater vascular permeability, which is the #1 symptom of cerebral cavernous malformation. For all 4 of these treatments, 2 of them from each group were given pseudoephedrine. Again, being metha, I still couldn't get my hands on methamphetamine, so I used pseudoephedrine, which is a close second structurally. So given the pseudoephedrine treatment to 2 of these worms, I also stained all of these worms with a dye that actually glows in the dark when the reactive oxygenated species is activated. So let's look at the video. The top 2, keep in mind, are the controls or the strain that's treated with the mutation, and the bottom 2 are the ones that are not. And then the left one is the strain that's not given the treatment, and the right one is. So if you watch the video playing, you can see the top right actually glows in the dark. That's the one that's treated with the pseudoephedrine and given the mutation. Isn't that so neat? When you're given methamphetamine, this actually provides evidence of you contracting CCM further. So I guess you could say that methamphetamine use makes it more likely for someone to have CCM. But I know what you're thinking. Medha, I'm no pothead. How does this apply to me? Well, what you may not realize is that methamphetamine or amphetamine, a structurally similar compound, is the primary ingredient in Adderall. And just in 2021, a whopping 4 million prescriptions of Adderall were given out in the US alone. Pseudoephedrine is sold as Sudafed, a common over-the-counter medication. Given these statistics, it's important that we consider the effects of methamphetamine not as a central nervous stimulant, but also its impact as it crosses through the blood-brain barrier, because it's proving to be more harmful than we could have ever imagined. Methamphetamine and also pseudoephedrine could potentially lead to causes of CCM. It's a whole new can of worms. It's up to someone else and more people to find out what else causes these symptoms. Thank you.